Today we will take the principle of computer architecture. We call it Fpga in our school. This subject is consequence for the next subject of the microprocessor, and the microprocessor already consequence of the digital circuit design. In principle of computer architecture, we are going to explore the processor design and the other peripherals like memories and the other IOs. Then we will do the implementation by using Fpga, the Field Programmable Gate Array. Field Programmable Gate Array is a digital reconfigurable chip. Can design by using CAD tool. The CAD tool we're using in our school called Quartus 2. This Quartus 2 is the envelope for our design, and we can design by using many tools. These tools can be schematic, Hdl, or state machine, and QSys system. Fpga consider the only platform can be reconfigurable, and can you build any circuit, I mean digital circuit, then this digital circuit can be used on board, and the board that we use in our school DE2 and DE1 SoC. Then after we design by using Fpga, we can send our design to the board by using programming in Quartus 2. Quartus 2 originally came from Altera, then now it's come from Intel. Okay? Principle of computer architecture will explore in detail how we are going to address all the necessary topics or subtopics in microprocessor, starting from pipe planning, then to the spatial parallelism, or then the branch prediction technology. Now, when we're going to design using Fpga, we can use the Hdl language. One of the very familiar or common language is Vhdl language. This language consists of three main parts. First, the library, then the entity, then the architecture. Library, we will use the library to call all necessary components can be used in our design. Entity will be used to identify all IOs, input and outputs. Then the architecture will be used to identify the purpose of this design. So by using Fpga, we can design or implement simple logic circuit until microprocessor. Now we're going to explore the generation of the Fpga. Fpga originally come with just digital logic gates like AND or NOT. Then after that, the next generation come with the logic gates with the memory. We call it embedded memory. So rather than we use the memory of chip memory, that means outside the chip, then we can use embedded memory inside the chip. So we minimize the time can be used to access the data. Then the next generation come with the what we call it embedded functional unit like multiplier, shifter, incrementer. Then come with the bigger functional unit, we call it embedded processor like NIOS 2. Then this NIOS 2 now can be used as embedded processor to program by using C language. And current generation of FPGA that we call SoC have what we call it hard processor, and it's ARM processor. So this is our introduction for Puka. Then the next we will going to explore the detail of top level of our architecture, computer architecture for next session. Thank you so much and see you next week.